So in this video, I'm going to illustrate the multiplicative seasonal method using an example from the textbook, example 8.6. So in this example, this particular steam cleaning company has a demand for last 4 years, year 1, year 2, year 3, and year 4, that is given on a quarterly basis. Now, what they wanted us to do is that forecast the demand, customer demand for each quarter of year 5. But they know what the total demand is going to be, which is 2,600. But the unique thing about this problem is that the carpet cleaning business is seasonal with a peak in the third quarter and the trough in the first quarter. Now, we have learned so far about the time series methodologies like simple moving average, weighted moving average, exponential smoothing, regressions. All these wouldn't work on this data set because the data set has a seasonal pattern. That's why we have to a different kind of a technique, in this case the multiplicative seasonal method, to solve for forecasted values. The first step in the seasonal method is to figure out the average quarterly demand. So we know for the first year the total demand is 1000 and we have 4 quarters. Based on that, you can calculate an average quarterly demand, which is 250, and with that 250 compare actual quarterly demand 45 with this 250 and calculate the seasonal factor. So seasonal factor is 0.18 for the first quarter. What this 0.18 means is that the actual demand is 18% of the average quarterly demand. And if you do the same thing for the second, 335 over 250, which gives you 1.34. 1.34, so the second quarterly demand is 34% higher than the average demand. Do the seasonal factor for the third quarter, and the third quarter's actual demand is twice the average demand, right? And the fourth quarter, look at it, fourth quarter's demand is just the 40% of actual demand. So these are the seasonal factors for the first year, and you repeat it for the second year. So second year's total demand is 1200. 1200 divided by 4 gives you the average quarterly demand of 300. So using that average quarterly demand, you can calculate the seasonal factor for each and every quarter for the second year. For instance, the first quarter, the seasonal factor is 0.23. The second quarter, the seasonal factor is 1.23. Third quarter, the seasonal factor is 1.97. And the fourth quarter, seasonal factor is 0.57. So you can repeat this exercise for year 3 and year 4. So you will have a set of seasonal factor for year 3, set of seasonal factors for year 4. So as a next step, you have to calculate the average seasonal factor for the first quarter. Average seasonal for the first quarter is 0.2043. You take an average of all first quarter seasonal factors. That will lead to 0.2043. So next step is to take an average of all seasonal factors of second quarter, take an average of all seasonal factors of third quarters, which is 2.001. Fourth quarter is 0.4977. As the last step, we have to calculate the quarterly forecast for each and every quarter for the fifth year. Now, we already know the total demand for the fifth year is 2,600, and if you divide that by 4, you will get an average quarterly demand of 650. So by using 650 and this set of average seasonal factors, you can come up with the quarterly forecast for the first quarter. The forecast is 650 times 0.2043 average seasonal factor, which leads to 132.795. Similarly, for the second quarter, 650 times 1.2979, which leads to 843.635. Third quarter, the forecast is 1300. Fourth quarter, the forecast is 323.5 units. Hope you enjoyed the video. Appreciate your time. Thank you.